All right, here we are with the logarithms and exponential functions test review, problem 5 and 6. So first, before we dive into these problems, we want to refresh ourselves on the log laws. Let me see if I can get this out of the way. So there's our log laws right there. Got the inverse law, product law, quotient law, timber property. When we go from the left side to the right side, it's called expanding. From the right side to the left side, it's called condensing. Essentially, multiplication in a single log becomes addition in separate logs. Division in a single log becomes subtraction of separate logs. And if I have an exponent at the end of a log, I can drop it down in front of the log, is what those laws tell us. So I'm going to use the quotient law on 5a to rewrite this as log of u minus log of v, because the law that we just looked at showed us that division becomes subtraction. In this next example, I can see I'm going to use the timber property at some point. But first, I want to simplify this expression that's in parentheses here. So log base 3 of x to the 24th, y to the 4th. Now each variable has its own individual exponent, which makes the next step easier. So I can apply the timber property and the product law at the same time to get 24 log base 3 of x plus 4 log base 3 of y. Now I can go to letter C, so same idea. First I want to rewrite the expression simplifying the exponent, so u to the 5th over v to the 15th, because when you have a power to a power, you multiply the exponents. So now I can use the quotient law and timber property at the same time to get 5 log base 6 of u minus 15 log base 6 of v. And then lastly, I can think about this 3, this cube root. I could replace it as a 1/3 exponent because the square root is a 1/2 exponent, so third root is a 1/3 exponent. And now I can get 1/3 times ln of x plus ln of y using the product law here plus ln z, but I ran out of room. And then I can distribute that. And so that's 1/3 ln x plus 1/3 ln y plus 1/3 ln z. Or I could write ln of x over 3 plus ln of y over 3 plus ln of z over 3. Going now to condensing, same thing, but we're using the laws in reverse. So let me just rewrite this first, applying the timber property. So I'm going to have ln of 11 to the 3/2 power, and then ln of 10 to the 1/2 power. So let's just see if 11 to the 3/2 power can be simplified. It cannot, but a little trick I could do is I could write that as 11 cubed to the 1/2 power. So just to make this a little easier to see, let me put that in red. So there's the cubed exponent there. Now this is a little fancier than anything I expect you guys to do on the test. This problem got a little trickier than I meant for it to. But I can combine this now as ln of 7, and then 1/2 exponents means the square root. So 7 root 11 cubed, which I can break up as 11 squared times 11 times 10. So that's all under the square root because all of that was part of this 1/2 exponent. Now the square root of 11 squared is just 11, so that can come out. And so that becomes ln of 7 times 11, which is 77, root 11 times 10, which is 110. And that matches with the answer key. Again, more advanced of a problem than I meant for it to be. So nothing like that's going to be on the test. but it's still good practice. If you can do harder problems, it makes ones like B a little easier. So it's easier to condense logs when we're dealing with variables rather than numbers, because there's not as much computation. So I can apply the timber property here, log base 4 of x to the fourth minus log base 4 of z minus log base 4 of y squared. So I'm going to break this one up. If I use the quotient law on these two first, I get log base 4 of x to the fourth over z minus log base 4 of y squared. And so now I'm going to get another divided by y squared. When you have a fraction divided by a fraction, you can just apply this. When you have a fraction divided by a number, you can just apply the number that's being divided into the denominator of the original fraction. So I get log base 4 of x to the fourth over zy squared. Now we got another one with numbers, which is just going to make it a little bit more challenging. So I can do log base 5. It's the same concept as letter B, of 11 to the 6th power over 3 times 7 to the 5th power. That directly matches with the answer key, so we don't need to simplify all that computation inside there. Now on letter D, you're like, what are we doing with this? Well, this is a situation where we're applying the change of base rule. So they had some log originally, and they changed the base to base E, also known as ln. So the change of base rule says if I have the log B of A, I could break that up as ln A over ln B, for example. I'm using ln, you could use any base, but I'm using ln because they used ln. So that means that this original log was log base 5, because 5 is in the denominator, of 40, because 40 is in the numerator. All right, videos 7 through 10 will be in separate, problems 7 through 10 will be in a separate video. So hope you enjoyed this one.